Hello everyone, welcome back to our YouTube channel schoolquiz.com. As you know, my name is Danish Agarwal and I am teaching you chemistry of class 9 science. Okay. As we have started with chapter number 4, that is structure of atom, in which we have covered all the topics of chapter structure of an atom. If you have any doubt in any topic, you can watch my previous videos. Okay, and in this video we will discuss NCERT questions 1 to 5, which are given at the back of the chapter. Okay, no doubt you can get the solutions of the all the questions on Google, like, or in your school, but I will let you know how to write the question and how to understand. Proper understanding is must. Okay, so we will discuss each and every question of NCRT. In this video, we will discuss 1 to 5 questions of NCRT. Okay, so as you know, chapter 4, structure of structure of atom, structure of atom. In this video, we will discuss 1 to 5 NCRT questions. Okay, NCRT questions. So we will start with our question number 1, which says our question number 1 is compare the properties of compare the properties of electrons, protons and neutrons. Compare the properties of electrons, protons and neutrons. As you know, these all three are subatomic particles. That is electron, proton and neutron. And what are subatomic particles? Which can't be further subdivided, or we can say that which can't be further subdivided. Okay, so our three subatomic particles, first one is electrons, protons, protons, and third one is our neutrons. Okay, as you know, as you know that what are electrons? Electrons are negatively charged species which are present outside the nucleus. Or we can say that revolve in a orbit. Whereas what are protons? Protons are positively charged species which are present inside the nucleus. And what are neutrons? Neutrons are neutral species which have no charge. And it are also present inside the nucleus. And second other thing, I have let you know that why the whole mass of the atom lies in the nucleus. Why it is so? Because mass of electron is negligible as compared to mass of proton and mass of neutron. Okay, so we start. First, our point will be that electrons are negatively charged. Where protons are positively charged. And these are neutral. That means they has no charge. Neither positive nor negative. They are neutral. Second point I have already discussed. That what is the second point? That these are present outside the nucleus. These are present inside the nucleus, and these are also present inside the nucleus. Present outside the nucleus, or we can say that revolve around the nucleus. Okay, these are present inside the nucleus. And these are also present inside the nucleus. And third point, I have already told you that mass of electron is negligible as compared to mass of proton and mass of neutron. That is, mass of electron is negligible Mass electron is negligible. As you know, what is mass of electron? That is 9.1 into 10 raised to power minus 31 kg. Mass of electron is 9.1 into 10 raised to power minus 31 kg. So mass is negligible of electron as compared to proton and neutron. That's why we also say that the whole mass of the atom lies in the nucleus. Lies in the nucleus. Okay. Whereas mass of proton we will consider as mass of proton is 1 AMU, atomic mass unit, which is equal to what? That is 1.67 into 10 raised to power minus 27 kg. 1.67 into 10 raised to power minus 27 kg. Here you see 10 raised to power minus 27 and 10 raised to power minus 31. So it is 11,1836 times mass of proton and mass of neutron is 1836 times, or we can roughly say that 2000 times more than mass of electron. Okay, so mass of proton is 1 AMU and mass of neutron is also 1 AMU. Okay, mass of neutron is 1 AMU. So these are the 3 points. Okay, we will discuss one more. Like if it is negatively charged, so it will attracted towards, it will get attracted towards, and if it is negative, it will attract towards positive. It will attract toward positive charge. And it is positive charge, so it will attract towards negative charge, and it doesn't attract to either towards positive neither towards negative. So don't get attracted towards any charge, like neither towards positive neither towards negative, so we have discussed 4 major points that that creates that compare the properties between protons, electrons and neutrons. Okay, now we will move to second question. Duster. Okay, second question. I hope this question is clear to all of you. Understanding is must. If you understand a topic very well, you can write it very easily in the paper. Okay, if you have understanding about a topic, you can easily write in the paper. So understanding is must. Second question is, इस पॉइंट को हम स्टार लगा के भी लिख सकते हैं. दैट इज बिफोर प्रोसीडिंग सेकंड क्वेश्चन, मास ऑफ एटम lies in the nucleus because, or as we know, mass of electron is negligible as compared to mass of proton or neutron. Okay, so we can say that the whole mass of the atom lies in the nucleus. Now we will move to second question. That is, what are the limitations of Thomson's model of atom? So, okay, what are the limitations of Thomson's model of atom? First, you recall what is all about a Thomson model. Okay, what says Thomson model? Thomson model says there is a positive charge. Okay, there is a positive charge, there is positive sphere, there is a positive sphere, okay, in which electrons are embedded. Electrons are embedded. Okay, so but after that experiments, like Rutherford says that the positive charge lies at the center. The positive charge lies at the center, that is in the nucleus. That is in the nucleus. So it is a limitation of Thomson model, because according to Thomson model, it says atom is a sphere where positive charge is uniformly distributed. So, but as according to Rutherford, that positive charge lies in the center of the nucleus. So we will write it as, what are the limitations of J.J. Thomson of a model of an atom? According to J.J. Thomson, according to J.J. Thomson model of atom, according to J.J. Thomson model of atom, it says that positively charged, there it says there is a positively charged sphere. There is a positively charged sphere in which in which in which electrons are present. In which electrons are present, but in which electrons are present, but other experiments showed that that positive charge is present inside the atom, present only inside the atom, where it is present only at the center of the atom, present only at the center of an atom. Note, it is uniformly distributed. It is present only at the center of the atom, that is nucleus, and electrons revolve around the nucleus. So it was the limitation of Thomson model of an atom, which says that positive charge is uniformly distributed in which electrons are present. But other experiments, like the Rutherford experiment, showed that the positive charge present at the center, and negative charge like electrons are revolving around the nucleus. Okay, so this is the question number 2, that is, what are the limitations of Thomson's model of atom? Now we will move to our third question. Third question is, what are the limitations of Rutherford's model of an atom? What are the limitations of Rutherford's model of atom? So, as I have already discussed what are the limitations of Rutherford model of an atom in our topic, that is Rutherford model of an atom. But I will also discuss here that if any students interested in watching only NCERT questions, so he will also able to know what are the limitations of Rutherford model of atom, and we will cover all the NCERT questions. Okay. So third question is, what are the limitations of Rutherford's model of atom? What was Rutherford's model of an atom? It takes and gold foil It takes a gold foil, and most of the alpha particles, he strike the alpha particles. As you know that most of the alpha particles went straight without any deflection, which says that most of the space inside the atom is empty. And he says that electrons revolve around the nucleus. Electrons revolve like it is a nucleus, and it says electrons revolve around the nucleus, but he didn't tell about a specific path which was told by Bohr, that there are certain discrete orbits, there are certain discrete orbits in which electrons are revolving. As we know, electrons are electrons are charged species. Electrons are charged species, and as will they move it, they will accelerate and will radiate energy. And one time comes, like for example, this is the nucleus, and there are electrons are revolving, like electrons are revolving. One time comes when they radiate energy and comes inside the nucleus, and they falls into the nucleus, which states which will lead to the instability of the atom. But as we know, atoms are highly stable. So this is a limitation of Rutherford model of an atom, which was removed by Bohr. So it was a limitation is, as we know, electrons are charged species, and when will they accelerate, they will radiate energy. And one time comes when they fall into the nucleus, which makes the atom unstable. As we know but as we know, atoms are highly stable. Okay, so club these major points and make the answer. Or we can, if in 1 marks you can write it like that it doesn't explain the stability of atom. Okay, simply you have to learn that it doesn't explain the stability of the atom. So these are the major points, like as electrons will revolve around the nucleus, they will accelerate, and accelerated particles will radiate energy, and one time comes when they fall into the nucleus, which makes atom unstable. Okay, so these are the major points. Club these points and make your answer. Now we will move to our fourth question. Fourth question. Fourth question is, describe Bohr's model of an atom. Describe Bohr's model of atom. We have already discussed in our previous video, so we will discuss here in short, like what Bohr's model says, that here are electrons, and electrons are present in a certain discrete orbits. Electrons are present in a certain discrete orbits. So there are major two postulates. First one is, where there are major two postulates. Which one is, electrons are two postulates of Bohr's model, that only certain special only certain special orbits certain orbits known as discrete orbits known as discrete orbits of electrons. Discrete orbits of electrons are allowed inside the atom. inside the atom, like n equal to 1, this one, like n equal to 1, n equal to 2, they can't be present here, they can't be present here, they can't present here. There is certain discrete orbits where electrons can be present. And second one is while while revolving in such discrete orbits they will not radiate energy, they will not radiate energy, or we can say that they will not lose energy. As we have already stated, what was the limitation of Rutherford model, that it limitation like that electrons will revolve, and at one time they will fall into the nucleus. But Bohr has removed that, and he says in certain such discrete orbits they will not radiate energy and they revolve continuously and they will not fall into the nucleus. So he has given orbits like K, L, M, N. First cell is K, and then L, K, L, and then third one is our M, and fourth one is our N. K, L, M, N. Energy levels, he given that N equal to 1 for K shell, N equal to 2 for L shell, N equal to 3 for M shell, and N equal to 4 for N shell. N equal to 4 for N shell. So this was our question number 4, that is describe Bohr's model of an atom. Now we will move to question number 5. Question number 5. As we have already discussed all three models, we have now in question number 5 we have to compare all the properties of the different models. So compare all proposed models of an atom. So as we know that first one was Thomson, next one was Rutherford, and third one was Bohr. So you have to write it like that, in the form of comparing. As you already know what was Thomson model, what Rutherford model says, what Bohr model says. Okay, so Thomson model, Rutherford model, and Bohr model. According to Thomson model, it is a sphere of atom is a sphere of positive charge. Atom is a sphere of positive charge. ठीक है, in which sphere of positive charge, in center. Now we can write it as positive charge is present in the center called nucleus. ठीक है. And third one is Bohr, that is positive charge in center, same point, that is positive charge in center called nucleus. As like other point, second point is electrons are uniformly distributed, that electrons are uniformly distributed, in which electrons revolve around the nucleus. ठीक है, electrons revolve around the nucleus, in which electrons revolve in certain discrete orbits. discrete orbits where they will not lose energy. So it says atom is neutral, like positive charge is equal to negative charge, or we can say that atom is neutral, or we can say that atom is electrically neutral. So in third, this one is size of nucleus. Size of nucleus is very small, as compared to size of atom. As we know, 10 is power 5 times. Okay, and in Bohr, that the orbits are termed as n equal to 1, n equal to 2 for K shell, for L shell, n equal to 3 for M shell, and n equal to 4 for L shell. Okay, so these was the comparison between all the three models proposed for atom, that is Thomson, Rutherford and Bohr. Now these were the first 5 questions of NCERT which we have discussed. So in our next video we will discuss our 6 to 10 NCERT questions. If you have any doubts, students comment in our comment box section, and we will try to solve it out. So thank you very much to all.